Hello students, welcome back to my channel again. Today we are going to do class 9's the chapter polynomials, and this is the second chapter in your NCERT book, and this session is the first session on the chapter polynomials. So we need to know first the meaning of the word polynomial. Polynomial, it means many and it means terms, so it's many terms. But polynomial means actually many terms in its own words, but if we have only one term or two terms or three terms, then also we will be calling those as polynomial, but provided condition is there will be some certain characteristics. Now what are they? You must have seen up to class 8 that algebraic expressions in one variable. Here polynomial in one variable is our syllabus, so we will only discuss about one variable, like x square minus 2x or 3x cube plus 5x minus 1, or only 4x cube, or only 3x plus 2, like this, many more. So you can see these all type of expressions obviously of one variable, and the powers of the variables. Look at the powers of the variables. 1 means actually 1 into x to the power 0. 2 means 2 into x to the power 0. You can look at the powers. No power is negative. No power is fractions. So all powers are either 0 or positive. Powers must be 0 or positive. Then only we can say that the algebraic expressions is the polynomial in that variable. I'm writing it. Powers must be 0 or positive. This must be there. If the power is negative or if the power is fraction, then we will not take it as polynomial. That means 0 or positive and whole numbers. Whole numbers. So 0 actually comes into whole numbers and positive also comes into whole numbers. So we can tell that the powers must be whole numbers, not fraction, not negative. This is the main criteria of being polynomial for an algebraic expression. Now this we have written. Now you can see for the first one we have 2 terms. For the second one we have 3 terms. Here 1 term, here again 2 terms. So there may be 2 terms, 1 term, 3 terms, 4 terms and many more. So depending on the number of terms that a polynomial has, there are some different categories of polynomials. Okay, so there are classifications, or you can say types of polynomials. Classifications of polynomials. Okay, first one is depending on number of terms. So based on number of terms. If we have one term, then its name is monomial. Mo means one, mono means one, mial means term, nomial. So together monomial. Two terms, binomial. Bi means two, nomial means terms. Three terms, trinomial. Four terms, quadrinomial. From fifth terms, sixth terms and so on, we will be telling it as, this is pentanomial, hexanomial, like this you can tell, or polynomial with 5 terms. Polynomial with 5 terms, 6 terms, like this. Okay. So up to this normally it is being used, quadrinomial. Then coming to its next part, that is degree of a polynomial. Degree of a polynomial. Look at this. Degree is the highest power of the algebraic expression, that is polynomial. Degree is the highest power of the polynomial, highest power of the variable in that polynomial. So we will look at the powers. 2, 1, which is the highest power? 2. That means its degree is 2. 3, 1, 0, which is the highest? 3. That means degree is 3. Here the only degree is 3. Degree is 1. Okay. So we will write it down, that greatest power of the variable in the expression, that is its degree. Okay. Now depending on this degree, there are some types of polynomials. Number 1 degree. If it is having 1 degree, then the name is linear polynomial. 2 degrees, then it's quadratic polynomial. 3 degree, cubic polynomial. 4 degree, biquadratic polynomial. 5 degree, polynomial with degree 5. Okay, and so on. Degree 5, degree 6, degree 7, whatever. So up to this, usual names are given. Linear means 1 degree, quadratic means 2 degree, cubic means 3 degree, biquadratic means 4 degree. Okay, so these are two types of classifications of polynomials. One is based on terms, another is based on its degree. Now you might be thinking about, if anything having 0 degree. 0 degree means, suppose we have only the number 13. So 13 can be written as 13 into x to the power 0. So it has the degree 0. So what it will be called, means what is its name? Its name is constant polynomial. So this is called constant polynomial. That means it is having 0 degree. So the examples of constant polynomials everybody can make. Any constant number you take, and that will be a constant polynomial. And obviously there is a special feature, just to remember, constant polynomial will never have the variable with it. Okay. So in place of constant polynomial, one we can say that only the number 0. So 0 is also a constant polynomial and its special name is 0 polynomial. If the number only 0, then it is called as 0 polynomial. Obviously it is a constant polynomial, but its special name is 0 polynomial. Okay. Our next point is coefficients. What does it mean by coefficients of a variable? You think about a term of an algebraic expression. Suppose 4x square. And I'm asking you to find out coefficient of x square in this term. That means the multiplier except the variable is called its coefficient. That means if I am finding coefficient of x square, then we will be coefficient of x square. So here it will be plus 4. Obviously mention the sign for writing coefficients. I am giving another example that I wrote first like this. What will be the coefficient of x in this expression? Yes, it is plus 5, because you can see this is the term containing x, and in that term except x plus 5 is there, so plus 5 is the coefficient. Coefficient of x is cube, this is coefficient of x. Coefficient of x is cube will be plus 3. Okay. If it is minus, then we will take minus 5. If it is minus, then we will take minus 3. So this is the coefficient. Suppose now I am giving you an expression 4x cube plus 2. And I am telling you in this expression you find out the coefficient of x square. You think that x square actually is not there in this expression. So if the term is not there, that means the coefficient is obviously not there. Coefficient is not there means coefficient is 0. If the term is missing in the expression, that means coefficient will be 0. Okay. So these are all topics that I covered in the first session of this chapter, polynomials. I am repeating it again and I am giving you a very short idea, quick idea. Polynomial, and this polynomial degree, that means polynomial's power must be whole numbers. It can't be negative, it can't be fraction, it can't be negative, it can't be fraction. If a power we are getting as fraction or negative, that means that is not a polynomial. Now, types of polynomials or classification of polynomials based on number of terms. If one term we are getting, then we will be calling it as monomial, 2 terms binomial, 3 terms trinomial, 4 terms quadrinomial, 5th term onwards, 5 terms, 6th term onwards, we will be writing like polynomials with 5 terms. Coming to the next part, that is degree of the polynomials, that is greatest power of the variable in that expression. Now, depending on degree, there are some types of polynomials. 1 degree linear polynomial, 2 degree quadratic, 3 degree cubic, 4 degree biquadratic polynomial, 5 degree polynomial with degree 5, and so on. Now there is another special category, that is 0 degree. 0 degree means that in the expression or in the term the variable will not be present and it will be called as constant polynomial. And there is a special category of constant polynomial, that is the term only 0 and its name is 0 polynomial. Next topic is coefficients. Coefficients means the multiplier left over after the variable. So the multiplier which has been multiplied with this, obviously including the sign with the variable mentioned, that is the coefficients. So here x square's coefficient is plus 4, here x's coefficient is plus 5, x cube's coefficient is plus 3, constant term is minus 1. But here in this expression I told you to find out the coefficient of x square, but x square term is missing. Missing terms coefficient always will be 0. So this is all about today's session, students. In the next video we will meet with some different topic of polynomials. Till then, bye bye and thank you.